Welcome to Cryptonomics.
Proof of stake has been garnering a lot of attention recently as an alternative consensus mechanism to proof of work.
In this video, we will explain proof of stake in an easy to understand way.
Welcome back to Cryptonomics Basics, the series where we explain hard to understand concepts in an easy to understand way.
In today's video, we will talk about what proof of stake is, how it works, and if it is a viable alternative to proof of work.
Proof of stake, like proof of work, is a consensus mechanism to validate transactions, but the way they work is quite different.
Proof of work uses computers to solve complex algorithms to validate transactions and create new blocks and coins.
And with more computing power in the network and more coins mined, the mining difficulty increases, making it harder to create new blocks and receive rewards.
In proof of stake, on the other hand, instead of computers solving complex algorithms to validate transactions and create new blocks, the creators of a block is chosen depending on the wealth through a process called staking.
The stake is used to vouch for a block to be added to the blockchain. Basically, you stake your money on which transaction should be included in the new block.
In most proof of stake networks, coins will already exist and will thus not be mineable.
This leads to proof of stake not having block rewards, but instead the miners, or forgers as they are sometimes called when it comes to proof of stake, are rewarded with transaction fees.
Sometimes, in networks that include inflation in their protocol, newly created coins can also be awarded to forgers.
So, the big question is, how does proof of stake select its forgers?
In Ethereum's proposed Casper hard fork, where Ethereum switches to proof of stake, there will be a form of validation pool.
You stake your coin through a Casper contract, which locks in a set amount of Ether to be used in a validation.
According to Vitalik Buterin, the founder of Ethereum, anyone can join a staking round and each validator will receive a reward depending on how much Ether is staked.
The fee rewarded will be regulated, so it will be less if there are many validators and higher if there are few regulators.
But a network can't just select forger based on account balance, since this will make the network centralized toward the wealthiest individuals.
To counteract this, different methods of selections depending on the crypto is used.
One method is randomized block selection, where the next forger is based on the lowest hash value and the size of their stake. This basically makes the selection random.
Another method is called coin age-based selection, which takes into account the time the coins have been staked as well as the size of their stake. Once a block is forged, their coin age is reset and must wait at least 30 days to sign another block.
Both of these methods aim to make it harder for one single account to overtake the validation process, thus making it more democratic.
There's been a big debate about proof of work having high energy consumption and also requiring expensive hardware to mine.
Since the energy consumption is high in proof of work, it means that it's rather expensive to use this consensus mechanism.
This means that there is a threat that a network could become centralized, not through the actual consensus mechanism, but because most people can't afford to actually mine the crypto.
Since proof of stake requires less energy and cheaper hardware, it is more affordable to the average user, which is a great incentive to run nodes and participate in the network, and thus incentivizing decentralization.
Proof of work, although expensive to use, is also very expensive to hack. To hack a proof of work network, you will need to take control of majority of network validations.
This will give an economic disincentive to hack the network, since the cost of hacking the network would outweigh the potential benefit of hacking it.
Since proof of stake is potentially cheaper to hack, you need something to deter possible hacking attempts.
Buterin's solution in Casper is if a validator creates a false block, they will lose their deposited Ether in the Casper contract, and they will also lose their privilege in the network consensus.
Another deterring factor is simple economics. If an activator try and purchase a majority of all coins in a network, the price would rapidly appreciate, making the ordeal very expensive.
Proof of stake is clearly an interesting new concept in a rapidly evolving industry. Only time will tell if this consensus mechanism will be adopted to a large scale.
Thank you for watching another installment of Cryptonomics Basics. I hope you enjoyed watching this video.
If you liked this video, hit the like button and leave a comment, and subscribe to see more.